are being recorded. All right, John's question is page 428, number 29. 428, and it's actually on 429. Okay, so page 429, number 29. All right, so this is section 8-4 on radical equations. And here is the equation they gave us. X squared equals, excuse me, 21 minus the square root of x squared minus 9. Okay, so in radical equations, the first thing you want to do is isolate your radical. Since the coefficient of that radical is a -1, perhaps you're thinking that we should move it to the left-hand side, but I'm actually going to suggest that we keep this x squared here, subtract the 21 to bring it over to this left side, and then I'm going to keep that negative sign and my square root where it already is on the right-hand side, because I know my next step is to just square both sides. So do you see how the negative in front of the radical is really no big deal, because I'm just going to square it. All right, and then on the left side, remember you cannot square terms, you square the whole quantity. All right, on the left side, I'm going to get x to the 4th minus 42x squared plus 441. And then on the right side of my equal sign, I square my negative, that becomes positive. Then I square the radical, and the square root cancel each other, and I get the stuff inside. So x squared minus 9. All right, this is a quartic polynomial, degree 4. So I have x to the 4th. I'm going to subtract 1 x squared, so that gives me minus 43 x squared. And then I'm going to add 9, and I get plus 450. And so I've set my equation equal to 0. And even though this is not a quadratic equation, I'm going to factor it as if it is a quadratic equation. And I don't remember, actually, that will help me. I think 18, let's see, 3 red 2, 9, 2, 18, yeah. All right, so I'm going to take 450 and divide it by 18. Yep, 25 and 18 adds up to 43. There we go. Okay, so I'm going to put x squared here, another set of parentheses, x squared there. Both of my signs need to be negative, and then I'm going to have an 18 and a 25. Okay, so if you double check that, you will get negative 43x squared for the middle term, and then plus 450 equals 0. Okay, so this second factor, x squared minus 25, I see that that's a difference of two perfect squares. So that's going to factor into x plus 5 and x minus 5. Okay, and then I think I'll just leave my x squared minus 18 exactly like it is. All right, now keep in mind this is a 4th degree polynomial. That means there are going to be 4 zeros or 4 roots to this. So underneath my x plus 5, I'm going to write that x equals -5. There's one of my answers. Okay, underneath the x minus 5, if I set that equal to 0 and solve for x, I get x equals +5. So there's 2 answers. Okay, and then, excuse me, let me put this in a different color. I'm going to come up here and give myself a little bit of room here to deal with that x squared minus 18. So if I set x squared minus 18 equal to 0 and then solve for x, I'm going to add 18 to both sides. Then I'm going to take the square root of both sides, but I know that this is a quadratic, so of course, do not forget, hold on, I'm going to get that beautiful purple. Do not forget the plus or minus. When you take the square root of both sides of a quadratic equation, don't forget the plus or minus. Okay, so left side I get x, right side I get plus or minus, and then my square root of 18 splits up into the square root of 9 times the square root of 2, so I get plus or minus 3 rad 2. So there's 2 answers two more answers. I'm going to write them underneath right here. X equals plus or minus 3 rad 2. Ooh, that was a bad 2. 3 rad 2. All right, so I have 4 answers. That should make sense since it was an x to the 4th equation. However, I need to go back and plug them back in because we squared both sides of our equation, and that can produce what's called extraneous roots. And so you have to plug all 4 of these back in. But when you plug in the 5 and the negative 5, they do not work. So those are going to get rejected. And then what I would do with the 3 rad 2 and the negative 3 rad 2, I would plug it into my calculator and store it, and then plug it back into the original, and those both do work. Okay, so this is my final answer, x equals plus or minus 3 rad 2. And then if this was on the test, I would show on my answer column that negative 5 and positive 5 both got rejected. Okay, and those are called extraneous roots. Okay, moving on to our next question. All right, John, I hope that was helpful. All right, Josh, the square root of x plus 3 plus the square root of x minus 2 equals 5. All right. That was very good how you wrote that. Okay, so always with radical equations, you want to isolate your radical. You can isolate either one, but if one's more complicated than the other, then I would recommend you do that. Why don't we isolate the radical that has x minus 2 inside of it, just since it has a negative sign, I guess. And then on the right side of my equal sign, then I'll have my 5, and then I subtract the other radical, x plus 3. Okay, so now I'm ready to square both sides. Remember, on the right side, I have 2 terms. You do not square terms, you square the quantity. Okay, the left side is the easy one because the square and the square root cancel. So I just get x minus 2 equals. Then I'm going to use my little pattern for squaring a binomial. I get 25. Then I multiply those 2 terms and double them, so double it. So I get minus 10, the square root of x plus 3. And then when I square the second term, I always get a plus sign because I'm squaring that. And then when I square my radical, I just get x plus 3. Okay, so in this expression or equation that I just got, I see that I have still a square root. So now I start basically all over again and I say, okay, let's isolate this square root. All right, so, excuse me, let's go ahead and add it to the other side. So I'm going to make it positive 10 times the square root of x plus 3, then my equal sign, and I'm going to bring everything else over to the right-hand side. So when I subtract x, my x's will end up canceling. So I'll cross those out. Okay, and then if I combine my 25 and my positive 3 on the right-hand side, that's 28. But then I'm going to add 2, so I get 30. Okay, now since 10 is a factor of 30, I'm going to go ahead and divide both sides. But if it wasn't, say I had gotten a 31 over here on the right side, then I would leave the 10 exactly where it was, and then it would be part of my squaring. Okay, but here the 10s cancel, so I have the square root of x plus 3 equals 3. I'm going to square both sides. I get x plus 3 with no radical equals 9. And then subtract 3, and I get x equals 6. Now I have no idea if that's the final answer because not only did I square both sides, I did it twice. You have to go back and plug it in. All right, let me do that in green. So if I plug in a 6 here for my x and a 6 here for my x, let's see what happens. So 6 plus 3 is 9. Principal square root of 9 is 3. Okay, and then for my second term, 6 minus 2 is 4. Principal square root of 4 is 2. And 3 plus 2 does equal 5. And so it does work. And so this is good. And my final answer. Okay, so you don't always get an extraneous root, but you do have to check for it always in these radical equations. Okay, that was Josh's question. All right, Noah, 5 divided by the cube root of 32. Okay. All right, 5 divided by the cube root of 32. All right, so I just kind of want to warn you guys that some of the two problems that I just did was solving a radical equation. That was a big section in our chapter. And then this section that I'm doing for Noah's question is a huge section. There are so many different types of situations when you're simplifying radicals. So don't take that section lightly. There's so much in there. You need to make sure you practice all the different types. Okay, so as soon as I see 32, I immediately recognize that that's 2 to the 5th. I'm not convinced that you guys all see that. And if you're my student, you know that I really, really emphasized making flashcards. And so you should see that 32 and immediately go, I know that. It's 2 to the 5th. All right, so I'm going to think of this cube root of 32 as the cube root of 2 cubed, because that's a perfect cube, and then times the cube root of 2 squared, which is my leftover stuff. Okay, this first radical, the cube root of 2 cubed, that's the cube root of 8, which equals 2. So that cube root of 32 that was in the denominator simplifies to 2, and then I still have a cube root. Yes, it would be of 4, but I'm going to write of 2 squared. All right, let me rewrite this to clean it up a little bit. So I've got 5 in my numerator. In my denominator, I've simplified that cube root of 32 to be 2 times the cube root of 2 squared. All right, now I don't want a cube root at all in my denominator. I want to rationalize this. So I have to multiply by a cube root, of course, so make sure you put that little 3 there. And then I want to make this 2 squared become a perfect cube. So isn't it going to be 2 to the first? That will make it a perfect cube. Because then I will get, let me go ahead and write it right here. I still have my 2 outside of the radical. Then I'll get the cube root of 2. And then when you multiply like bases, you keep the same base and you add the exponents. So see, we just forced it to be a 2 cubed, which is a perfect cube. So let me go back to the denominator. I have 2 times, and then when I take the cube root of 2 cubed, I get 2. And so my denominator is now 4, and it is rational. All right, coming back up here where I am circling in red, this is where I multiplied or decided I was going to multiply the denominator by the cube root of 2. Well, you have to do the same thing to the numerator because we can only multiply by a clever form of 1. All right, so I'm going to go straight from that numerator to my final answer right here. So my numerator is going to be 5, the cube root of 2, and then all of that over 4. Okay, that is how you simplify that. All right, I suppose I could show you a little bit different technique. Instead of simplifying that cube root of 32 from the beginning, you also could have said, this is the cube root of 2 to the 5th, and then wouldn't multiplying by the cube root of 2 to the 1st give me the cube root of 2 to the 6th, and that is a perfect cube, and you get 4, or 2 squared. Okay, then I go back to my numerator and say I have to multiply by the same thing that I did to my denominator, and of course I would get the exact same answer. Okay, all right. Let's see. That was Noah's question. All right, Noah, it was number 3 on the group quiz. All right, yes, I do have that, so there you go. Okay, Melissa, can I do number 11 on the group quiz, please? Yes. All right, number 11. So quiz number 11. All right, it says the square root of x plus 4 plus the square root of x minus 4 equals 4. All right, you truly can isolate either radical. I probably would suggest isolating the x minus 4, the square root of x minus 4. So on the right side of my equal sign, I'll have 4 minus, and then my radical x plus 4. Okay, now I'm ready to square both sides. I square that radical, and then on the right side of my equal sign, I have 2 terms. You do not square terms, you square the quantity. All right, left side, I will get x minus 4 because my square and my square root cancel each other out. Then on the right side, squaring a binomial happens over and over and over again. I hope you guys are realizing the pattern is so easy if you recognize it. So you don't have to write it out, 4 minus the radical times 4 minus the radical. I can just say, you square the first term, that's 16. You multiply the two terms together and double it. So that's minus 8 times that same square root. And then finally, you square the second term. So anytime you square something, it becomes positive. And then squaring a radical gives you the stuff inside. Okay, so this is very similar to a problem we did earlier where I said that, look at this, we still have a radical. So we're going to isolate that. I think I'll bring it over to the left-hand side. It becomes positive 8, the square root of x plus 4. Then on the right-hand side of my equal sign, I want to bring everything else from the left to the right. So if I subtract x, those go away. If I add 4 to both sides, let's see, I will get 8 plus that is 24. So my 16 plus 4 on the same side of the equal sign adds up to 20, and then when I add 4, I get 24. Okay, so quite a few of these we've seen where the coefficient of the radical just happens to be a factor of whatever number we get over here. So when that's the case, then I would divide through by it, makes your numbers smaller. And I get the square root of x plus 4 equals 3. I'm ready to square both sides, and so that gives me x plus 4 on the left side equals 9, and then I'm going to subtract 4, and I get x equals 5. Okay, now not only did I square both sides of my equation, I did it twice. You absolutely have to go back and plug it in to see if it works. Okay, so I'm going to plug in a 5 here for x and a 5 here for x. So 5 plus 4 is 9, and the principal square root of 9 is 3, plus 5 minus 4 is 1, and the principal square root of 1 is 1. And since 3 does equal 4, my answer is correct. X equals 5 is not an extraneous root. That is the final answer. Okay. Let's see. All right. That was Melissa's question. Savannah, 1 minus 1 over rad 3 divided by, oh, okay. By the way, if these are questions from the quiz, you can just say the quiz number. Nope, that's not from the quiz. Okay, so 1 minus, where'd that just go? 1 over the square root of 3, and then all of that divided by 1 plus 1 over rad 3. Okay, very good. Alrighty, so there are two issues here. One issue is that we have a complex fraction. That means we have these little baby fractions in my big fraction. You want to take care of that first. So this to me is the easiest way to do that, and that is to multiply by the least common denominator of all of your minor denominators. So let me circle my minor denominators. This is a minor denominator, and this is a minor denominator. So the least common denominator of those two is rad 3. So I multiply by rad 3 over rad 3. And then this is imperative that you understand this. You must distribute that rad 3 to each of the two terms in the numerator and each of the two terms in the denominator. Okay, so in the numerator, my 1 times rad 3 is rad 3. And then when I distribute it to the second term, doesn't the rad 3 in the denominator cancel with the rad 3 in the numerator, and I just get minus 1. Okay, doing the same thing in the denominator, I get rad 3 plus 1. So we got rid of the complex fraction issue, and now the only issue I have, excuse me, is that I still have a radical in the denominator. Since that's two terms, we need to multiply by the conjugate. So it's rad 3 minus 1, and whatever I multiply the denominator by, I have to multiply the numerator by the same thing. So that's my clever form of 1. Okay, in the denominator, my rad 3 times rad 3 is 3. My outers and inners are going to cancel. That's what happens with conjugates. And then I get minus 1. So my denominator is a 2. And now I'm going to multiply the numerators. So my rad 3 times rad 3 is 3. This time my outers and inners do not cancel. I get -1 rad 3 minus another 1 rad 3, so I get -2 rad 3, and then my -1 times -1 is +1. All right, I want you to watch how I'm going to write my next step. My 3 plus 1 is 4. Then I still have -2 rad 3, and right here's where I want you to pay super close attention. I am not going to write all over 2 because you guys make so many mistakes when you do that. Please just split it up. Okay, this over 2, first term over 2, and second term over 2. And then simplify each of those terms separately. Because within the first term here, the 4 divided by 2, those are all factors. And you can see that it simplifies to 2. And then in the second fraction, the 2 and the rad 3 and the 2, those are also factors. So I can cancel those, and I get minus rad 3. So 2 minus rad 3 is my final answer. Okay, that was Savannah's question. All right, Josh, you didn't ask. Okay, John, quiz number 13 on the back side. Okay, so this is part A, B, and C. All right, so it says the number of feet it takes to stop a car after the brakes are applied varies directly with the square of the speed and inversely with the coefficient of friction between the car tires and the road. Assume that on a dry road, the coefficient of friction is 0.8 and it takes 45 feet to stop when your speed is 30 miles per hour. Okay, before we start dealing with all those numbers, I want to try to write a general equation, and I'd like to pick some variables that make sense. I don't want to just use X and Y. Okay, so as I read this again, it says the number of feet it takes to stop a car. So I used F for feet. Okay, you could have used D for distance. You could have said B for brakes. Okay, I mean, you have a lot of choices. All right, but it's number of feet it takes to stop a car, so I'm calling it F for feet. Okay, then I'm going to put my equal sign. It says the number of feet it takes to stop a car after the brakes are applied varies directly with. So varies is a verb, so that's my equal sign. Every variation problem has to have a K, and it's a numerator, so just write equals K. And then it says that the number of feet it takes to stop a car after the brakes are applied varies directly with. So I know it's going to be K times whatever they're going to tell me next. Okay, varies directly with the square of the speed. So I'm going to use S for speed. And if we were together in class, I'd be asking you, does this mean the square root or S squared? Well, it means S squared. It does not say square root. It says the square of the speed. So please read that carefully, and you cannot leave that 2 as an exponent out. You have to have that there. All right, so varies directly with the square of the speed, and then it says, and it varies inversely with the coefficient of friction between the car tires and the road. So inversely means I'm going to have a fraction. So inversely, or divided by, and then for coefficient of friction, maybe you were thinking of using F for friction, but I already used F for feet. So I'm going to use C for coefficient of friction. Okay, now I go back and reread. By the way, this is called the general equation. This is generally speaking how F and S and C are all related, but I don't know the specifics because I don't know what K equals yet. So here's why they give you that information so you can solve for K. Assume that on a dry road, the coefficient of friction is 0.8. So I know my denominator is 0.8. And it takes 45 feet to stop. Okay, so that's my distance in feet is 45 feet to stop this experiment when your speed is 30 miles per hour. So I have K times and then 30 is what's going to get squared. All right, so I use my calculator. I would take 45 and multiply it by 0.8 and then divide it by 30 squared, which is 900. And when you do all of that, you get K equals 0.04. And that is exact. If it was not exact, then we would write the exact answer. Okay, but this is a terminating decimal. So there's my answer. And so let me write my particular equation. Let me write that out. You guys had a hint of this in your last chapter. And I just have to say that I was really, really surprised and disappointed that some people don't know how to write a particular equation. Now that I have k solved for, I'm going to write this equation, and I'm purposely going to write something in a different color. So k being 0.04 is the only difference between the particular equation and the general equation. This general equation, of course, has the k in it. And now the particular equation has k solved for and the number written in there. So now I know exactly how f and s and c are related to each other. Okay, so that's the equation. Then they asked you some questions. Number 13b said determine how many feet of skid marks Lisa Carr left on the road when coming to a stop on a dry road. So they said dry road again to make you understand that you're going to have the same coefficient of friction. And it says she's going 50 miles per hour. All right, so I take my equation. F equals 0.04 s squared all over c. Then they told me my coefficient of friction was 0.8. They told me that Lisa's going 50 miles per hour, 0.04 times 50 squared. And we are solving for how many feet? So we are looking for F. Okay, so when we plug that all in, we end up getting 125 feet. And make sure you use the units. This is a word problem. Okay, last question, 13C, says Lisa Carr left 200 feet of skid marks coming to a stop on a dry road. So see how they said it again, dry road, so that we know it's the same coefficient of friction. All right, so 200 feet for F, then 0.04. It says, how fast is Lisa driving? That means I want to know the speed, so I'm looking for that. And then 0.8 is our same coefficient of friction. Okay, when I solve for s squared, I get s squared equals 4,000. That 4,000 was gotten by taking 200, multiplying it by 0.8, and then dividing both sides by 0.04. All right, so when you do that, you get, what did I say, 4,000. So then I take the square root of both sides, and I get approximately, it is not exact, let me change that to a squiggly equal sign. I get approximately 63.25, and the unit for speed is miles per hour in this example. Okay, and there is my answer, okay, saying that it's approximately. All right, then, I don't know why they asked this. Was Lisa speeding? I don't know if you guys think 63 miles per hour is speeding. It depends where she's driving. Is she driving on a freeway? Is she driving on a residential street with a bus sitting there? So don't worry about answering that question. That will not be asked of you on the test. Okay. Ella, I'm doing this GVL from 7:30 to 8:30. Okay. All right. Let's see. Did I do 13? I just did 13. Okay, so John, that was yours. Jade, can I do number 3 from the group quiz, please? Yes. Oh, I already did it at the beginning of this. All right. Caitlin, the answer to number 4 on the quiz. All right, 4 is probably making you suspicious that maybe you did something wrong because nothing combines, and it's very dissatisfying. I agree. All right, but I want to show you guys a little trick. So the square root of 3 minus the square root of 8 times square root of 6 plus the square root of 5. All right, I imagine most of you probably just multiplied straight out. So you went the square root of 3 times the square root of 6 is the square root of 18. Then you went the square root of 3 plus the square times the square root of 5, but with the plus sign in front of it. So plus rad 15. Then your inners, negative rad 8 times rad 6 is minus square root of 48. And then finally minus the square root of 40. Okay, if you did that, I'm very concerned that you're going to leave your answer that way. Okay, so I have a suggestion for you. Well, I'll go ahead and simplify this the way I would if that's the first step that you took. I would split up the square root of 18 into the square root of 9 times the square root of 2. 15 you can't do anything with. This square root of 48, though, probably initially you'll think that it's a 4. That's the perfect square. That's a factor, and that's true. 4 is a factor of that, but it's not the biggest factor. It would be 4 times 12, and then 12, I know, has another 4. So it's actually 16 times 3. So here I'm going to get 4 the square root of 3. Over here I'm going to get 3 the square root of 2. And let's talk about square root of 40. I see that I have the square root of 4 times the square root of 10. And so here I get minus 2 the square root of 10. By the way, I don't want to forget about this, plus the square root of 15. And so this is my final answer. And there was a minus sign here. And isn't that just kind of dissatisfying? Not one single term can be combined with another. There are no like terms in this. So that's your final answer. Okay, here's the shortcut trick I wanted to show you. This square root of 8, I'm going to simplify it before I start multiplying it out with other things. So isn't it the square root of 4 times the square root of 2? So I get 2 rad 2. Okay, so I'm going to do that here instead of the square root of 8. Then the square root of 6, even though this doesn't simplify it, I'm going to write it as the square root of 2 times the square root, of 3. Do we all agree that the square root of 2 times the square root of 3 is the square root of 6? All right. I need to rewrite that because I didn't have enough room. So, I'm going to read it from my quiz. All right, square root of 3 minus 2 rad 2. So I've simplified my square root of 8 right there. Then I'm going to rewrite the square root of 6 as square root of 3 times the square root of 2, and then plus the square root of 5. All right, when I go to do my firsts, isn't the square root of 3 times the square root of 3 equal to 3? So I get 3 the square root of 2. Completely simplified. Okay, then when I distribute the rad 3 to the rad 5, that's just a plus square root of 15. Okay, for my inners, I'm going to look at the negative and the 2, but then I'm going to multiply the rad 2 times rad 2. That is also 2, so that 2 times 2 is 4. So I get minus 4 the square root of 3. Okay, and then finally, my 2 rad 2 times the square root of 5. That's going to be minus 2 the square root of 10. Okay, and that should be the exact same answer that we had before. Back. 3 rad 2, plus rad 15, minus 4 rad 3, and then minus 2 rad 10. There you go. Same answer, a little bit easier, I think. Okay, let's see. I see quizzes number 4, 7, and 6. 4 I just did. Okay, 7, and then 6 we just did a problem very, very similar to it. But okay, number 7 on the quiz. So it's the 5th root of negative number, and then that 1024, I recognize that as 2 to the 10th power. Okay, so if having a negative inside of a radical, certainly should give you pause and you should think about it. But if I multiply something by itself 5 times, if it's negative, and I multiply it by itself 5 times, won't I get a negative? Okay, so it's okay to have that negative inside a fifth root. It would not be okay if it was a square root or a fourth root or a sixth root, but in a fifth root, it is okay because of that odd index. Okay, so I think I'm going to rewrite this as negative 2 to the 10th, okay, and the 2 to the 10th can be separate from the negative, okay, it's always going to be negative. And then instead of writing the fifth root, I'm going to write to the 1/5 power. Do you guys agree the fractional exponent 1/5 represents the fifth root of? So I have a negative sign, and then 2 is my base, and then 10 multiplied by 1/5 gives me squared. And so there is my final answer. And if you want to double check it, you take your -4 and say, what would happen if I raised that to the fifth power? Well, because it's to an odd exponent, for sure I would get negative. And then you can do your 4 to the fifth in your calculator, and you will get 1024. Okay, so that's just to double check that this was indeed correct. Okay, that was number 7. Number 6 on the quiz. Like I mentioned, this is very similar to one that we did before, except for it was a rad 3 instead of the rad x. All right, but I'll do this one also. So this is quiz number 6. It says 1 plus 1 over the square root of x all over 1 minus 1 over the square root of x. Okay, so just like we discussed before, I'm going to look at my minor denominators and multiply it by the least common denominator of those minor denominators. All right, so I'm going to multiply it by the square root of x over the square root of x. And the most important thing is to say I'm multiplying every term by the square root of x. Okay, so 1 times the square root of x is the square root of x. Then my second term, I'm going to look at my denominator because I have a little fraction there, and the rad x is going to cancel with the rad x, and so I just get plus 1. Okay, in the denominator, 1 times the square root of x is the square root of x, and then minus, I look at my fraction, the denominator is going to cancel with the square root of x, and I just get minus 1. Okay, we got rid of the first problem. That was having a complex fraction, little baby fraction in the big fraction, but now I have a secondary problem. I don't want x to be in the denominator, excuse me, the square root of x. So I'm going to multiply by the conjugate. So the square root of x plus 1 is what I want to multiply that by. Okay, so I feel like I need to write this out because I'm a little too scrunched over here. That was my numerator. Here is my denominator. And so I'm going to multiply it by the conjugate. So square root of x plus 1 and square root of x plus 1. Okay, in the denominator, square root of x times square root of x is x. My outers and inners cancel, and I get minus 1. So x minus 1 is my denominator. The numerator is going to be square root of x times square root of x is x. Then I get plus 2 times the square root of x plus 1. And not a thing can be simplified in that. Okay, that was number 6 on the quiz. X plus 2 rad x plus 1 all over x minus 1. Very good. Okay. Okay, so Caitlin, the answer to number 6, I just did it. There you go. X plus 2 rad x plus 1 all over x minus 1. Okay. All right. Cassidy, could I do number 13 on the quiz? I already did. Phoebe, can I do number 1 on the quiz? Sure. Okay, they gave us a function, f of x, and it equals 6 plus the square root of x minus 1. So the first thing they ask for is find the domain of x so that the function is a real number. Well, if I have a variable expression inside the radical, I know I do not excuse me, I know I do not want the stuff inside to be negative, because if it was, then that would not be real. Having a negative inside of a square root is what gives us imaginary or complex numbers. So I'm going to take that x minus 1 and say it needs to be positive or 0. Here's how you write that. Greater than or equal to 0. I just know that it cannot be negative because that would not be real. So the stuff inside can be 0 and it can be positive. Those are the two things it can be. So now when I go to get x all alone, I say I need to add the 1 to both sides, and I get that x needs to be greater than or equal to 1. Okay, and that's my domain. Okay. B asks you to plot f of x in the domain from positive 1 to positive 10. And I did a few of those points, but not all of them. I didn't do all the integers. So I did x equals 1, x equals 2, and I skipped to x equals 5, and I did x equals 10. Okay, so just choosing a few key points that are going to be good, smart choices for x. When I plug in 1 for x inside the radical, I end up getting 0. And so the square root of 0 is 0, and so my y value is 6. Okay, when I continue plugging these in, I'll get 2, 7, 5, 8, and 10, 9. But did you guys notice that in the domain it said 1 is less than or equal to x, which is less than 10. There's no equal sign on the 10. So look what I'm going to do on my chart. I'm going to put an open circle right there on my chart just to make sure I don't forget. Okay, when I go to graph this, go like this. My x's, I'm going to go all the way to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, then my y's also seem to go up like that. So I'm going to go up to 9. So 1, 2, 3, 4, 5, 6. I'm going to label 6, 7, 8, 9, 10. Okay, so I have the point 1, 6. That's, let me do this in red. 1, 6 is right there. Then I have 2, 7. Next I have 5, 8. By the way, I'm going to label that 1, 2, 3, 4, 5, and 8. Okay, so 5, 8. And then 10, 9. There. Okay, oops, but 10, 9, we said open circle. Good thing I had that little hint right there. So I'm going to connect those points. And that is the top half of a parabola. And it starts at the point 1, 6, but it does not terminate at the end point of that. It's an open circle, okay? And it doesn't keep on going. Normally it would keep on going all the way to the right, but because of that not having an equal sign, that's why we end it with an open circle. Okay, I'm getting very, very tired. I hope I just didn't say something wrong. All right, is the back side of the test going to be all word problems? Yes. And Isabel, can you do 1C on the chapter review? Yes. Okay, this may or may not be the last question. Okay, chapter review 1C, so R1C. Okay, it's a little bit related to a problem like this. Oh, by the way, I didn't finish one on the quiz. All right, I graphed it. I answered part A, the domain, okay, but part C and D say to find f of 26. So of course you're just going to plug in a 26 instead of the x and figure out what your y equals. So 26 minus 1 is 25. Principal square root of 25 is 5. And then 6 plus 5 gives me 11. So that's the answer for part C. F of 26 equals 11. And then part D says find x if f of x equals 12. So I suspect some people are going to plug in the 12 for x, and that would be very wrong because it said f of x equals 12 and then find x. So on the next page, let me write that down. 12 equals 6 plus the square root of x minus 1. Okay, so to solve this, we're trying to solve for x. I'm going to subtract 6 from both sides. I get 6 equals the square root of x minus 1. Then I'm going to square both sides. So I get 36 equals x minus 1. And when I go to simplify for x, I add 1, and I get x equals 37. So that's the x value for when y equals 12. Okay? All right. Now let's go to Isabel's question on the review assignment. So this is, let's see, page 453. Page 453. And I'm doing R1C. Okay, so in R1, they started out by telling us that f of x equals 7 minus the square root of x minus 3. All right, so they asked you to tell the domain, they asked you to find f of 28, and now they're saying find x if f of x equals 1. So instead of this f of x, I'm going to plug in a 1. If I subtract 7 from both sides, I'll get negative 6 equals negative the square root of x minus 3. Sometimes I'll have people ask me, can you take that negative in front of the radical and distribute it inside the radical? You do not ever want to do that. You would never do that with a 3 and say, oh, can I put the 3 inside the radical? No, it's outside of the radical. So that negative stays right where it is. Okay, but I have now, actually I would probably multiply both sides by a negative 1. And so that becomes positive, that becomes positive. And so that's taken care of, okay? Then I'm going to square both sides here. On the right side of the equal sign, I can square a positive 1, but of course I keep a positive 1. Then when I square the radical, those cancel and I get the stuff inside. So x minus 3. Okay, on the right side, I need to square that as well. So I get 36. And then I need to solve for x. So add 3 and I get 39. Okay, let's see, that was R1C, and that's the correct answer. X equals 39. Okay. Cassidy, do I want you to do all the R's with no exclusions? Yeah, I never did go back and look at that. R5 is good. R6 is good. Yeah, and there's only 6 of them. So yes, it's actually a pretty short assignment, isn't it? So yes, R1 through R6, and I'll send a reminder out about that. That's not due till Friday, okay? Right now I want you to make sure that you have your group quiz done. That's what we'll go over tomorrow. Okay, if you guys have any other questions, ask quickly. We have about 10 minutes left. But if I've answered all your questions, we can also end early. Okay, nobody's typing, so we're going to stop right there. All right, I hope that was helpful for you guys, and I will see you tomorrow. Good luck on your tests on Friday. Kenji, you're welcome. Aurora, John, if you're saying thank you. Oh, John, you waited too long. You're welcome, Aurora. All right, let's look at John's question. 429.33. 429. Okay, this is a good question. It is kind of a combo question. This is page 429, number 33. Here's what I mean by a combo question. At first, when you look at it, you're like, oh, it's one of those radical equations. It is, but it's a radical equation with a fraction in it. And so students in my class know that I say whenever you see a fraction in an equation, get rid of the denominators first. So the only way I can get rid of the square root of x minus 7 is if I multiply the entire equation by the square root of x minus 7. Hey, I know what we should do. We should meet my puppy. Bear, come here. Bear, come here. Let's say hi to Bear. That will help wake me up. Okay. Hi, Bear. Look, he got his hair cut. So he looks all cute like a little schoolboy, and he has his little scarf. Isn't that so cute? His little scarf. Say hi, Bear. Say hi. Okay. Do your homework, get good grades, and happy Thanksgiving. That's from Bear. All right. Here you go, puppy. Okay. All righty. Now, see, I'm invigorated to do more math. All righty. So I am going to distribute. That's what I did with the little red arrows. Is I'm distributing that square root of x minus 7 to each and every one of these terms, whether it's a fraction or not. So the first term is square root of x times the square root of x minus 7. I'm going to write it as 1 square root, and it's the square root of x times x minus 7. Then I put my plus sign, and my square root of x minus 7 times the square root of x minus 7 is just the stuff inside, x minus 7. Then I have my equal sign. And then when you get to this third term, the fraction, don't you dare write 21, the square root of x minus 7 over x minus 7. No, the x minus 7s, or the square root of x minus 7 rather, cancels with that. Remember, that was the whole reason we were multiplying by that, was to get rid of the denominators. So let me say it again. Anytime you have fractions in an equation, get rid of the denominators first. All right, so now look at my new equation. No more fractions, yay. And I have one radical. So it's the square root of, I'm going to go ahead and multiply that inside. So my x distributed gives me x squared minus 7x. And then everything else I'm going to bring to the right side of the equal sign. So I'm isolating my radical again. Okay, so I'm going to add 7 first. That gives me 28. And then subtract x. Now I'm ready to square both sides. When I square my left side, the square cancels with the square root, so we get x squared minus 7x. On the right side, where's my calculator? I don't know what 28 squared is. 28 squared is 784. 784 minus 56x plus x squared. So at first I was thinking, yikes, I'm going to have some big numbers to have to factor. But look at what happens, you guys. When we subtract x squared from both sides, they cancel. I don't even have a quadratic equation. Okay, I'm going to add 56x to both sides so that I get a positive coefficient. And so I'm going to get 49x on this side. My 784 stays over here. And let's see what 784 divided by 49 is. A nice, neat 16. So I get an integer. There are two reasons, though, in this problem why 16 might be an extraneous root. The first possibility is that since I had a fraction in my original equation, if 16 gives me 0 in the denominator, of course I will reject that. Well, that's not the case. So I'm going to need to check to see if 16 satisfies this equation. Let me do this in green so it stands out. So 16 right here for my x, another 16 here, and a 16 down here. All right, let's see what happens. The square root, principal square root of 16 is 4. So there's my first term. Plus 16 minus 7 is 9. Principal square root of 9 is 3. And then on the right side of my equal sign, I have a 21 over, and then the principal square root of 9 is 3. And do you agree? 7 equals 7. And so 16 works, and so it's not an extraneous root, and that is my answer. Okay. John is typing again. Awesome. Thank you. You're welcome. All right. We're going to call it a night, and again, good luck on your test on Friday. And happy Thanksgiving, everybody. All right. Have a nice evening. Bye-bye.